right, so this one is going to be a little bit different. It says let the graph of G be a translation 3 units right and 2 units up, followed by a reflection in the y-axis of the graph of f of x equals x squared minus 5x, and write a rule for G. So there's a lot of things going on here. The first thing that you should have noticed is that we don't just have the parent function f of x equals x squared. On this one, we're subtracting 5x from it. So that's a little bit different, okay? So some things that I would like to note for you here is that this is different. We have f of x equals x squared minus 5x. That's a change. Okay, so it says let the graph of G be a translation 3 units right. So we're going 3 units right. That's important to note. And we're also shifting 2 units up. Okay, followed by a reflection in the y-axis. Okay, so this part right here, we're going to kind of like table it, which means just put it aside for just a second. And we're going to focus on what's in the purple, because that reflection we can do a little bit later. And once again, where it says write the rule, I'm going to put it right below. We want an equation. That's all that's meant by that. Okay, so here's what we have. We have the graph of, and I'm going to write this kind of expanded out, okay? We have the graph of f of x. We want to make it become g of x. So what if I was to say that g of x is going to equal, I'm going to take f of x and I'm going to move it 3 units to the right. Okay, so what happens with, I forgot once again. Hold on just a second. Okay, so I wanted to put our vertex form equation here just so that we can have it kind of sort of like as a review. Okay, we're going to go 3 units to the right. So we're going to let h be 3. So what's going to happen is we're going to replace what we have here with what we have here. So let me show you what that's going to look like. I should have moved that over a little bit more. Excuse me, because I can do this. Okay, so I'm going to start over here. We're going to say g of x is equal to, and here's how I'm going to deal with this moving to the right. I'm going to put some parentheses and I'm going to shift it to the right in both cases for x. Okay, so here's what it's going to look like written out. Okay, I'm going to have open parentheses x minus 3, and that's going to be squared, and then we're going to subtract 5 times x minus 3. And so that is how I deal with the fact that this has to shift to the right 3 units. Okay, and then it also needs to go 2 units up. Well, that 2 units up is the same place as my k value here. So since I'm going up all the way up, I'm adding 2. Okay, so that looks like a mess, and that's quite all right. So what we can do with all of our wisdom, we are going to simplify this. Okay, now to simplify this, I'm going to move this out. We're going to come back to what's in the green, reflection in the y-axis. First, I want to simplify this. I want to follow my order of operations. Okay, so what I'm going to deal with here first, I got a square and I have a set of parentheses. I know I cannot subtract x minus 3. Okay, because this does not have an x term on it. So instead, what this is, I'm going to write it, expand it out over here, kind of, sort of. Let's see here. So this x minus 3 squared is the same thing as x minus 3 times x minus 3. Now at this point, I can use up all of this area here to explain this. You have 2 ways that you can attack this to simplify it. Okay, your first method that you can use is the box method, which We've done it, it's just been a while. So we would set up our little box here. See there? My line's all crooked. And we would do x minus 3 and x minus 3. Well, what happens is everything inside the box gets multiplied, kind of like a Punnett square. X times x is x squared. X times negative 3 is a negative 3x. X times negative 3, negative 3x. Negative 3 times negative 3, positive 9. Now, if this is going by kind of quick for you, remember you can rewind it, or you can replay it, or you could take a picture of it if you just don't understand it, okay? And let me know. So now what we're going to do, so this step right here, we multiplied, and now what we're going to do is combine like terms. So x squared, there is no other x squared term there, but we have a negative 3x and another negative 3x. That's like me borrowing $3 and borrowing 3 more. I will owe you $6, and there's no other constant, so plus 9. This can be used to replace what we have here. Okay, now, big old or. You don't like the box method. You are used to using FOIL. It just depends on what school you came from, what you choose, or what you like to use, okay? If you don't like the box, you can use FOIL. X minus 3 times x minus 3, okay? With FOIL, why we call it FOIL, we do first. The first two terms multiply here, and we get x squared. We do the outer terms. Outer two terms multiply, x times 3, negative 3, and we get negative 3x. Then we do the inner term, negative 3 times x, and we get negative 3x. And then we do our last terms, negative 3 times negative 3, and we get a positive 9. All of those things get added together, and we get the same x squared minus 6x plus 9. Okay, if that is something you don't understand, let us know. You want to know how to multiply a binomial. Okay, that is what we're doing right here. Okay, so what I'm going to do is I'm going to let this right here replace what we have here, and I'm going to rewrite it here. So here we go. I'm keep looking because I'm so scared that I'm going to write outside the frame where you won't see it. So x minus 3 squared gets replaced with x squared minus 6x plus 9. Then what we have here, we've already taken care of that. This minus 5 times x minus 3, treat this as if this is a negative 5 times x. So we are multiplying, so we would have a negative 5x, and then a negative 5 times a negative 3 plus 15, and then we have that same old plus 2. Okay, so all we did here to get to this step was we multiplied. Okay, so here's where we started and here's where we are now. Now what I'm going to do is combine like terms. Okay, once again, we can always look and see if we got some terms that's alike that we want to combine. So g of x equals x squared. There's no other square term in here. Then we have alike a negative 6x and a negative 5x, or minus 6x and minus 5x. Either way, I borrowed $6, I borrowed 5 more, I owe you $11. So minus 11x. Then the next thing that we have here is a positive 9, positive 15, so that's 24, plus 2 is 26. So we have a positive 26. Okay, so that is what we would have if all we did was transform x squared minus 5x 3 units right and 2 units up. Now what we want to do is deal with the fact that we have to reflect this in the y-axis. Okay, so remember with a reflection in the y-axis, if I hold my two fingers here like this is our parent function of our parabola, and if we reflect it in the y-axis, what happens is it does that. Okay, so even though it looks exactly the same, it's just reflected on that y-axis. So that's what we want to look at right now. So that was the part that was in green. We're not finished just yet. Okay, so right in here. Now, what we want to do is consider if we reflect in the y-axis. Let's see here. Do I have it? Okay, this is from the notes from the core concept. If we reflect in the y-axis, we put a negative in the parentheses with the x value. So that's what I'm going to do. I'm going to put me some negatives inside the parentheses. Now, let's see what that's going to look like. So each one of these will get a negative with it. So here we go. I am going to, let's see here, because we're not done with g of x here. Okay, we need to put a negative with the x squared, and this is going to represent what happens when we reflect it in the in the y-axis. Excuse me, y'all, I just don't want to say the wrong thing, and then I'm trying to get the colors right so that it's stand out so you can see. I didn't get them colors right. I didn't put that as black. Okay, never mind. Okay, so here's what happens. Small, tiny mistakes with Miss Gable. That's what I'm going to call these videos. Okay, so g of x, we're not finished with it. But what I want you to notice is that a negative x squared, it just becomes a positive x. Because what happens is, I'm going to put it over here. Make a little note for yourself. A negative x squared is the same thing as negative x times negative x. Well, two negatives multiply and you get a positive. Okay, so for that reason we have x squared. Nothing changed there. But we got a negative 11 times a negative x. That's going to become a positive 11x. You know what else? Something I showed a group of people this in tutoring, and maybe it'll help you out too. I used to have this on my board, and it looks like tic-tac-toe. All right, if it helps you out, great. But we would put positives on the diagonal and negatives everywhere else. Long as you got positives on the diagonal, you're good. This is kind of like your rule, not kind of. This is your rule if you are multiplying or dividing integers. Okay, I used to have this on the board because sometimes I know, you know, that I put an extra S in there. ERS. There we go. Multiplying or dividing integers. So what happens is you can read this horizontally, left to right, or you can read it vertically, and you get it right. So a positive times a negative is a negative. A negative times a positive is a negative. Two negatives multiply, and you get a positive. Same thing going horizontally. Vertically. Negative times a negative is a positive. Negative times a positive is a negative. Positive times a negative is a negative. So maybe that will help you if you get messed up with stuff like this, like negative times a negative. Well, we look right here. Negative times a negative, positive. All right. Yeah, so that's that. Then we got our plus 26. All right, I just wanted to put that there. If you don't have that in your notebook and you know you struggle with multiplying and dividing integers, won't you go ahead on and write that down? Don't be stubborn, okay? Let Miss Gable help you out. All the coaches, you know, we all here to help you. We just really be wanting y'all to say something, okay? So that's going to be our transformation of x squared minus 5x, 3 units right, 2 units up, and reflected in the y-axis. Okay, so if you got questions, just let us know. We are here to help you out as best as we can, okay? Now, y'all have a great day. I love that song.